This topic is essential in understanding the basic principles of motion, which form a key part of the IB Physics syllabus. As we go through this material, we'll clarify how direction and magnitude play a role in motion, and how to quantify changes in position and velocity over time. Let's start by breaking down these concepts to build a solid foundation for the rest of the course. When we talk about motion, it's important to understand the difference between scalars and vectors. Scalars are quantities that have only magnitude, like distance, speed, time, mass, and energy. These tell us how much, but not the direction. On the other hand, vectors include both magnitude and direction. Examples of vectors are displacement, velocity, acceleration, force, and momentum. You can think of a vector as an arrow pointing in a certain direction, showing not just how much, but where it's going. This distinction helps us describe motion more precisely and is essential for understanding how objects move and interact. Here, we're looking at the difference between distance and displacement. Distance refers to the total length of the path you travel, so it takes into account every twist and turn along the way. Because it measures the entire route, distance is always a positive value. Displacement, on the other hand, is more straightforward. It's the change in position from the starting point directly to the end point, regardless of the path taken. It's like drawing a straight line from point A to point B. This makes displacement independent of the path, and its value can be positive, negative, or zero depending on direction. Importantly, the distance will always be equal to or greater than the magnitude of the displacement, since the traveled path can't be shorter than the straight line between the start and end points. When we talk about measuring rates of change, speed is a scalar quantity that tells us how fast something is moving without regard to direction, and it's calculated by dividing the distance traveled by the time taken. On the other hand, velocity is a vector quantity, which means it does include direction, and it measures the rate of change of displacement over time. In IB notation, it's important to remember that S represents displacement, not speed, which differentiates velocity from speed. This distinction helps us understand motion more precisely by considering not just how fast an object moves, but also where it's going. When an object moves in a circle at a constant speed, its velocity is still changing because velocity depends on both speed and direction. Even though the speed remains constant, the direction of motion continuously changes as the object moves around the circle. This means that the velocity vector is always changing, which implies there is acceleration present, specifically centripetal acceleration. So, acceleration can occur without any change in the speed, simply due to the change in direction. Acceleration is defined as how quickly velocity changes over time. This means it measures the rate at which an object's speed or direction changes. In the example shown, the object's velocity increases from 1 second to the next, and the change in velocity over this time period represents acceleration. Mathematically, acceleration is the velocity divided by the time it takes for that change, and its unit is meters per second squared. It's important to note that acceleration can result from changes in speed, direction, or both. So even an object moving at a constant speed can be accelerating if it's changing direction.
When we talk about deceleration, it's important to understand the relationship between velocity and acceleration vectors. Deceleration happens only when these two vectors point in opposite directions. For example, if an object has a positive velocity, meaning it's moving forward, and its acceleration vector points backward, it will slow down. Conversely, if an object has a negative velocity, moving backward, and its acceleration vector points forward, it will also slow down. This means negative acceleration doesn't always mean the object is slowing down. It depends on the direction of the velocity. So the key point is that deceleration is about the opposing directions of velocity and acceleration, not just the sign of acceleration alone.
To fully describe motion, we need to understand the difference between scalar and vector quantities. Scalars only have magnitude, like distance and speed, which tell us how much but not the direction. Vectors, on the other hand, include both magnitude and direction. For example, displacement is a vector that shows how far and in what direction something has moved. Similarly, velocity adds direction to speed, and acceleration describes how velocity changes over time, including its direction. Without vectors, our description of motion would be incomplete because direction is essential to accurately conveying how objects move and change their motion. This table summarizes these concepts clearly, highlighting how vectors provide the full picture.